Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in this particular video, I am going to discuss the detailed solution of 6th question of free maths mock test for JEE Main 2026. The question is in front of you. It says the number of points of non-differentiability of function fx equal to GIF of mod x minus 1 plus mod x minus 2 plus mod x minus 3 in open interval minus 10 comma 10 is, where GIF denotes the greatest integer function. Now students, in this question we have to find the total number of points where the given function fx is non-differentiable in the open interval minus 10 comma 10. Now first of all, I will simplify the expression mod x minus 1 plus mod x minus 2 plus mod x minus 3. Now students, it's very much obvious that the given expression in the modulus sign will change its definition at 3 points. That is at x equal to 1, at x equal to 2 and at x equal to 3. So to simplify this expression, I will divide the given interval into 4 subintervals. The first is when x is greater than minus 10 and less than 1. In this interval, x is smaller than 1. So obviously x is smaller than 2 as well as x is smaller than 3. So that means this particular expression will become equal to 1 minus x plus 2 minus x plus 3 minus x. Because we know that mod x is equal to minus x when x is negative. So that means this becomes finally 6 minus 3x. Right? Now students, we move further. Now students, we discuss the second subinterval. In this subinterval, x is greater than or equal to 1 and less than 2. Now since x is greater than or equal to 1, so mod of x minus 1 is just equal to x minus 1. Mod of x minus 2 will be equal to 2 minus x and mod of x minus 3 will be equal to 3 minus x. So the value of this expression becomes equal to 4 minus x. Now in the third subinterval, when x is greater than or equal to 2 and less than 3, the expression becomes equal to x minus 1 plus x minus 2 plus 3 minus x. So that means this is just equal to x. And in the last subinterval, when x is greater than or equal to 3 and less than 10, since x is greater than 1, x is greater than 2 and x is also greater than or equal to 3. So mod of x minus 1 becomes x minus 1, mod of x minus 2 becomes x minus 2, mod of x minus 3 becomes x minus 3. Because we know that mod of x is equal to x when x is greater than or equal to 0. So this becomes 3x minus 6. Right? Now students, we will finally describe the definition of the function fx in all the subintervals. Now students, I can write fx equal to GIF of 6 minus 3x when x is greater than minus 10 and less than 1. Fx is equal to GIF of 4 minus x when x is greater than or equal to 1 and less than 2. Fx equal to GIF of x when x is greater than or equal to 2 and less than 3. And fx equal to GIF of 3x minus 6 when x is greater than or equal to 3 and less than 10. Now students, I will discuss these two particular cases. That is the interval when x is greater than or equal to 1 and less than 2, and when x is greater than or equal to 2 and less than 3. Now, when x is greater than or equal to 1 and less than 2, then minus x becomes greater than minus 2 and less than or equal to minus 1. So that means 4 minus x becomes greater than 2 and less than or equal to 3. So I can say that in this particular interval, GIF of 4 minus x becomes equal to 2. And this happens when x is greater than 1 and less than 2. Because at x equal to 1, the value of fx becomes equal to GIF of 4 minus 1, which is nothing but 3. Right? So it's very much clear that at x equal to 1, the function fx becomes discontinuous. Right? Because the value of fx when x is slightly greater than 1 is 2, and at x equal to 1, the value of fx is 3. Both of them are different. So the function becomes discontinuous at x equal to 1. This clearly implies the function will also be non-differentiable at x equal to 1. So this is the first point of non-differentiability. Now students, we move further. Now students, when x is greater than or equal to 2 and less than 3, then f of x is defined as GIF of x. So clearly its value is equal to 2. And we also know that when x is greater than 1 and less than 2, then in this particular interval fx is also equal to 2. So that means I can merge both of these conditions and say that fx is equal to 2 when x is greater than 1 and less than 3. Now since fx is a constant function in the open interval 1 to 3, so this clearly implies that fx is differentiable at all values lying in the open interval 1 to 3. Right? Now students, we discussed the interval when x is greater than minus 10 and less than 1. In this particular interval, fx is equal to GIF of 6 minus 3x. And we know that greatest integer function becomes non-differentiable at all values of x for which its input becomes an integer. So now we will have to find the interval for 6 minus 3x. Now when x is greater than minus 10 and less than 1, then 3x lies between minus 30 and 3. So minus 3x is greater than minus 3 and less than 30. Just add 6 throughout this inequation. So 6 minus 3x lies between 3 and 36. Now students, between 3 and 36, how many integers are there? Clearly, there are 32 integral values possible between 3 and 36. So that means there are 32 points of non-differentiability for the function fx in the open interval minus 10 to 1. Right? Now students, we move further and discuss the last subinterval. Now students, we discuss the last subinterval when x is greater than or equal to 3 and less than 10. Now in this particular subinterval, fx is defined as GIF of 3x minus 6. Now we will use the same concept again. At all those values of x for which 3x minus 6 becomes an integer, at those values of x, fx will become non-differentiable. Now in this particular subinterval, 3x is greater than or equal to 9 and less than 30. So just subtract 6 throughout this inequation. 3x minus 6 becomes greater than or equal to 3 and less than 24. Now students, between 3 and 24, including 3, how many integers are there? Clearly there are 21 integers. So hence 21 points of non-differentiability of fx in this particular subinterval. Remember that I have included that value of x for which 3x minus 6 becomes equal to 3. Because when I put 3x minus 6 equal to 3, I get x equal to 3. So that means at x equal to 3, fx is non-differentiable. You can also check non-differentiability at x equal to 3 in this way, that when x is greater than 2 and less than 3, then the value of fx we found was equal to 2. And at x equal to 3, the value of fx becomes equal to 3. So that means both the values are different. Hence, the function fx becomes discontinuous at x equal to 3. So clearly, it is non-differentiable at x equal to 3. Now students, let's add all the points of non-differentiability. So in the open interval minus 10 to 10, there are 32 plus 1 plus 21 points of non-differentiability for the function fx. So this comes out to be 54. So hence option A is the correct one. Now students, in my tomorrow's video, I will discuss the 7th question of free maths mock test that I have posted just now. If you haven't watched that video, please watch that video as well and try to solve that question. In my tomorrow's video, I will present the solution of that question also. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.